rotor of three-phase induction motor. Sorry, take your phasor diagram for stator winding. So all the three phase will be excited by 120 degree. Phasor diagram for three-phase induction motor. Then we draw the three-phase AC diagram. From your three-phase diagram, in the three-phase diagram, take note, let theta is equal to 0 degree, theta equal to 0 degree. So 0 degree means it is your origin. So in this origin, we will be having three phases. What are the three phases? R phase, then here we have a B phase, and this one is your Y phase. At origin, your R phase value is 0. Therefore, flux due to R phase will be 0. Flux due to Y phase will be, it is in negative sign, so take it as minus. Flux in your B phase is positive direction. So with this we can conclude only two fluxes are interacting at a time. Now redraw this phasor diagram according to this condition. So in this condition, R phase is 0, Y and B phase are present. Y is in negative direction, B phase is in positive direction. So B phase in positive direction, in the B phase appear phi B. Y phase in negative direction. Negative direction is opposite the variable. So draw Y phase in opposite direction minus phi Y. So from this phasor diagram, this is your R phase. After 120 degree, in our Y phase, negative Y phase means take it in opposite direction. Take it as minus Y phi. Similarly for R, when you take it in opposite direction, it is minus phi R. Similarly for B phase, it will be minus B phase in opposite direction. Opposite negative. So in the diagram, let theta is equal to 0 degree na R phase illa. So appo inda R thevilla, negative direction thevilla. Vera enna theva? Y phase in negative direction, Y phase negative la irukumbodhu thevilla. B phase positive la irukumbodhu thevilla. So what is the angle between these two? R ku Y ku la angle da 120 degree. Y phase endradhu paadhila cut agudhu. Appo idoda angle enna varum? 60 degree. So here the angle is 60 degree. Now we need to find the resultant value. So resultant value of flux is sum of your B phase cos 30 will be equal to total flux divided by 2 divided by hypotenuse value. Find the value of phi t. See, take down first. 1.5 m. So when you take 0 degree as an angle as a reference, we have R phase as 0, we have B and Y phase. ரெண்டே ரெண்டு flux தான் interact ஆகும். Similar for 30 degree. இந்த மாதிரி ஒவ்வொரு angle check பண்ணீங்கன்னா you will be getting one phase will be acting as a 0 value, other two phases will be interacted. So this operation is similar to your single phase induction motor. Next one take as rotor. Rotor. So your rotor is classified into two types. First one we call it as slip ring or wound rotor. Second one we call it as squirrel cage rotor. Squirrel cage rotor பார்த்தோமா? It is similar to your single phase induction motor. In single phase induction motor, you will be having a single stator winding. Your rotor will be constructed in the form of squirrel cage. Squirrel cage na என்ன ஞாபகம் இருக்கா? Squirrel cage rotor. So your rotor will be in the form of cylindrical shape. So in this cylindrical shape, you will be having openings. This opening we call it as slots. Rotor will be cylindrical in shape. In your cylindrical shape, you will be having a opening called as slots. Over this slots only we will be placing your conductor. So for conductor, what we are using? This conductor will be made up of aluminum or copper bar. So this is your front view of squirrel cage induction rotor. So when you go for a side view, we will be having one more shape. So here we will be placing a copper or aluminum bars. End is short circuited, so therefore we rotor, rotor is slip ring induction rotor, slip ring. It is also called as wound rotor. So your slip ring induction rotor will be similar to your stator winding. Your stator can be either star or it can be either in star fashion or it can be in delta fashion. So mostly we will be considering star connection. Take down slip ring induction rotor. Take down the diagram. See, take the next topic as effect of rotor. Effect of rotor. Effect of rotor. See, take down your stator. It is rotating in synchronous speed. So what is the formula for your synchronous speed? Ns will be equal to 120 F divided by P. We know single phase induction motor or a three phase induction motor is not a self starting motor. அதனால என்ன பண்ணிருக்கோம் நம்ம your induction motor is not a self starting motor, therefore we will be making your induction motor as a தானா அது சுத்தாது சொன்னேனா ஏன் சுத்தாது north pole south pole immediately change over ஆகும்போது rotor will get confused whether it should align with clockwise direction or anti-clockwise direction. அதனால தான் நம்ம என்ன பண்ணிருக்கோம், we will be providing a external winding and we will be making your rotor to rotate either in clockwise or anti-clockwise direction. So your rotor speed is not similar to your stator speed, correct? So இப்போ rotor ஓட speedங்கிறது n ன்னு எடுத்துக்கலாம். Rotor speed, so it is not equal to your stator speed. So it is ns minus n, we call it as relative speed. Relative speed. ns stands for stator speed. N stands for rotor speed. It is always less than your stator speed. So the difference between ns minus n, we call it as relative speed. So using this we can write ns minus n relative speed divided by ns. We call it as slip of induction motor. Important 2-mark question. Slip of induction motor. It is the ratio of relative speed to the stator speed. We call it as slip. Slip is usually measured in terms of percentage. So slip in percentage will be equal to ns minus n divided by ns into 100. Important 2-mark question. ns ங்கிறது ஸ்டேட்டரோட ஸ்பீடு, n ங்கிறது ரோட்டரோட ஸ்பீடு. ஸ்டேட்டர் ஸ்பீடு ரோட்டர் ஸ்பீடு எப்பொழுதுமே சிமிலரா இருக்காது. So there will be a difference. It is taken as ns minus n called as relative speed. So the ratio between relative speed to the stator speed we call it as slip of induction motor. Usually your slip will be represented in terms of percentage. Percentage na into 100 multiply பண்ணனும். ஓகேவா? So this is called as slip equation of induction motor. So from that we are going to write effect of rotor. Effect of rotor. So let when your stator speed, we know stator speed n is equal to 120f divided by p. If we are considering relative speed, then your equation will become frequency will be changed as fr, that is rotor speed. We know slip is equal to ns minus n divided by ns. Therefore this equation will become 120 fr divided by p divided by 120 f divided by p. So here 120 and number of poles will get cancelled. So it is fr divided by f. So we know ns minus n is equal to slip fr divided by f. From this rotor frequency will be equal to s times of supply frequency or stator frequency. Effect of rotor will be always s times your stator value. புரிஞ்சுதா இதை எப்படி எழுதுனேன்னு? So generally stator speed na 120 f by p, f by number of poles p. So இப்போ நான் relative speed rotor is consider பண்ணும்போது frequency வந்து change ஆகும். சரியா? So frequency change ஆகிறதுனால fr ன்னு ரெப்ரசன்ட் பண்றேன். So ns minus n divided by ns ங்கிறது ஸ்லிப் நமக்கு தெரியும். அதனால இந்த ஈக்குவேஷனால இதை டிவைட் பண்றேன். டிவைட் பண்ணா fr divided by f ன்னு கிடைக்கும். So s will be equal to fr divided by f. So fr will be equal to s times of f. அப்படினா என்ன எழுதலாம்? Rotor effect on frequency will be equal to slip times of your supply frequency or stator frequency. இதை s ன்னு எடுத்துட்டது stator ன்னு எடுத்துக்கோமா. அதனால இந்த frequency stator frequency சொல்லலாம். ஓகேவா? இதுவே நான் reactance போட்டேனா reactance will be represented as x2 rotor side reactance. So rotor side x2 will be equal to s times of x1. ஓகேவா? இந்த மாதிரி நம்ம ஈக்குவேஷன் எழுதுறோம். இது மட்டும் போதும். ரோட்டரோட கன்சிடர் பண்ணும்போது ஸ்லிப்பை கன்சிடர் பண்ணி தான் நம்ம ஸ்டேட்டர் சைடு கன்சிடர் பண்ணணும். ஓகேவா? நெக்ஸ்ட் ஒன் டேக் த டார்க் ஈக்குவேஷன். Induction motor is also called as a asynchronous motor, otherwise rotating transformer. So transformer ல இருந்து ஒரு term நமக்கு இம்பார்ட்டன்ஸ் சொல்லிருக்கேன். என்ன terms so transformer ல நமக்கு கேங்கிற ஒரு வேல்யூ கொடுப்போமா, அது என்னது? turns will be equal to E2 divided by E1. Since induction motor is also called as a rotating transformer, here also we can use turns ratio. called as a rotating transformer. Here we can use turns ratio. Turns ratio. Now take down torque equation of induction motor. Torque equation of induction motor. Torque equation of induction motor. Take down the torque equation depends on